Consider the following reversible reaction. FeF2 solid 2H plus Fe2 plus 2HF. Right. So this is an equilibrium reaction and K is the equilibrium constant of the above reaction. This equilibrium is reached through the following mechanism. Right. So they have given the mechanism and this is the final reaction, and from these two steps it reached to the final step. So we can make this final reaction from these two steps, right? So I can name this one as 1 and this one as 2. We have 1 FeF2, so we can write it in the same way, FeF2. Then we have 2H plus. So H plus is from this equation. This equation has H plus. In order to make 2H plus, I have to multiply this equation by 2. Then only I can get 2H plus. Then Fe2 plus, 1 Fe2 plus. So here 1 Fe2 plus is there. Then 2HF. 2HF. So we are multiplying this second equation by 2. Therefore, we are getting here 2HF. Right. So when we add these two, what are we getting? So we no need to reverse this reaction, this second reaction, because all the ones are in the same way, right? FeF2 in left side. So here also FeF2 is on left side in the first equation. 2H plus is on the left side in this reaction, and here also 2H plus is in left side. So the sides are in same direction. So we no need to put the minus sign in order to reverse that reaction. So when we add 1 and 2 times 2, we can get FeF2 plus 2F minus plus 2H plus equilibrium Fe2 plus 2F minus and 2HF. Then 2F minus to 2F minus cancel. Then we are getting this same reaction. Right. So this is the reaction. Now as I add 1 plus 2 times 2, this becomes what? Our final equilibrium reaction becomes what? K1 times K2 squared. How does K2 squared becomes? Because here we multiply this second reaction by 2. Then this K2 value becomes squared. Why? Because this becomes 2HF and we are dividing it by 2F minus 2H plus. Right? Then if we do this, we are getting like this now. Which means K2 has become what? K2 has become squared. That's why we are taking the square value of that. Now if you multiply this equation by 3, think if you multiply this by 3, then you have to take K2 to the power 3. Likewise. Right? So that's why we take here K2 squared. So our final equilibrium constant is K equals K1 times K2 squared. So when we calculate our K, K1 is 2 into 10 to the power minus 6 mol 3 dm minus 9, and K2 squared is 1 into 10 to the power 1 into 10 to the power 3, right? Mol minus 1 dm3. Right, so no need to So let's again write it. K1 is 2 into 10 to the power minus 6 times K2 is 1 into 10 to the power 3 square. Now here you are getting 2 into 10 to the power minus 6 times 1 into 10 to the power plus 6. Plus 6 minus 6 cancel. So the answer is 2. So K equals 2. Therefore K is greater than 1. Now select the answers with K greater than 1. So this is the only answer we are getting, right? K is greater than 1. Then see the other one. The position of equilibrium lies close to products. How does it becomes true? Now here we get K equals 2. Now how can we find the equilibrium constant? We have to divide this product's concentration by the reactant's concentration. So if we are getting a higher value for K, it means our product's concentration is high. So that means the position of the equilibrium lies close to the products. So the answer is 3. Right. Now next question 22. Which of the following statements regarding carboxylic acids is incorrect? Which of the following reactions regarding carboxylic acids is incorrect? Right, incorrect statement they are asking. First one, carboxylic acids cannot be reduced to alcohols with sodium borohydride. Yes, that is correct. Why? Because carboxylic acids can be reduced to alcohols by lithium aluminium hydride. Carboxylic acids can be reduced by lithium aluminium hydride, not sodium borohydride. Right? So the first is correct. Now sodium borohydride, we can use sodium borohydride for the reduction of aldehydes and ketones. And for lithium aluminium hydride, by using lithium aluminium hydride, we can reduce aldehydes and ketones, carboxylic acids, esters and amides, right? So carboxylic acids cannot be reduced to alcohols with sodium borohydride, that is correct. The boiling points of carboxylic acids are higher than the boiling points of alcohols with comparable relative molecular masses. Now for the boiling point, we have to consider two factors. What are the two factors? One is the intermolecular interactions and the other is the molar masses. Right? We have to consider the intermolecular interactions and the molar masses. Right? So now here they are telling they are having comparable relative molecular masses. So we no need to consider about their molecular masses because it is same now. Next we can go for the intermolecular interactions. So we have to consider about this intermolecular interactions. Now what happens with alcohols? And alcohols, they have ROH and carboxylic acids have RCOOH. So here alcohols form the hydrogen bond with this hydroxyl group, but carboxylic acids, they can form two hydrogen bonds. One is from this one and also from this O. It can form two hydrogen bonds. So there is more hydrogen bonds in carboxylic acids. Therefore, the boiling point of carboxylic acid is higher than the boiling point of alcohol. So this is also correct. Third answer. Carboxylic acids react with aqueous sodium hydroxide with the evolution of carbon dioxide. So what can you say about it? If I erase this thing. Carboxylic acids, we can take RCOOH with sodium hydroxide gives RCOO minus sodium plus plus H2O. So it does not give carbon dioxide. So this statement is wrong. And that is the answer. Third is the answer. Answer 3. Carboxylic acids can form, Carboxylic acids can form dimeric structures due to hydrogen bonding. Yes. How? Now this is the RCOOH group now. So here it can form hydrogen bonds, and from here also it can form hydrogen bonds with another carboxylic acid. Like this. Right? So it can form dimers like this. So that is correct. Fourth is also correct. Water solubility of carboxylic acids decrease with increase in relative molecular mass. Yes. Because now carboxylic acid has two parts now. RCOOH now. We are having RCOOH. Now they are asking with increase in relative molecular masses. Increase in relative molecular masses means this R group becomes larger. Right? R group becomes larger. Then what happens? This is non-polar. R group is non-polar. This non-polar group becomes larger. Then the water solubility decreases. Water solubility decreases as a result. So fifth is also correct. So the answer is 3. Next 23rd question. CH3OH gives CO plus 2H2 and delta H naught is given 91. Right? So here delta H naught is 91 kilojoules per mole, which means this is positive. Right? Positive delta H, which means this is an endothermic reaction. Now what happened in an endothermic reaction? They are asking the above reaction occurs to completion in a thermally insulated closed rigid container. Which of the following is correct regarding the temperature of the contents in the container? Now what happens to the temperature of the contents in the container? It decreases. Temperature decreases. And what happens to the decreases means you have either second answer or third answer. So it can be plus or minus. So how can you find the sign of delta S naught? What is delta S naught here? Delta S naught means the entropy change. Right? Entropy change now. So how can you get it? Now this is a gaseous state reaction. CH3OH is a gas and it gives carbon monoxide, which is also a gas, plus 2H2, which is also a gas. So this reaction occurs in the gaseous state. Here there is one gas molecule and here there are 3 gas molecules. So what happens? The randomness is increased. You all know when more gas molecules are there, the randomness increases. So when randomness increases, what happens for the entropy? Entropy increases when randomness increases. So entropy becomes plus. So the answer is second one. This is the answer. Answer 2. Next, 24th question. A closed container equipped with a piston contains an ideal gas at temperature T and pressure P1. So temperature T, pressure P1. The volume occupied by the gas is 2 dm cube. When the volume is increased to 5 dm cube at the same temperature, the pressure is changed to P2. Which of the following statements is correct regarding this system? Right, so the temperature is constant, pressure has changed and the volume has changed. Now if we take PV equals nRT equation, N is constant, R is constant, T is constant. So PV equals constant. That is Boyle's law. Right? So we can apply P1 V1 equal P2 V2. Then we are having here P1 times 2 dm cube equals P2 times 5 dm cube. Then when we get a relationship, now they are asking with relation to P2, right? P2. So if we subject P2, P1 times 2 over 5, which means 0.4 P1 equals P2. Now 0.4 P1 is in third answer and the first answer. Then they are giving the other one is average kinetic energy. What happens to the average kinetic energy of the gas? Now average kinetic energy depends on what? The temperature. So here the temperature is constant. So this is also constant. Average kinetic energy depends on the absolute temperature, which means the temperature in Kelvin. So here the absolute temperature is same. It is not changed. So the temperature is constant. Therefore the average kinetic energy of the gas remains the same. Right? Therefore the answer is 1 for the 24th question. Answer is 1. 25th question. Consider the reaction below occurring at a given temperature N2O CO given N2 plus CO2. The rate of the reaction is increased when the reaction is carried out in the presence of a small amount of palladium powder. Which of the following best explains this observation? Right, so they are telling that rate is increased. Rate is increased when small amount of palladium powder is used. Now, when small amount of a catalyst is used, you all know the rate is increased. So, palladium should be a catalyst. So, the question indirectly tests about the knowledge of catalysts here. Right? First statement. Now, they are asking the statement which best explains this observation. How can you explain this observation in a best way? Right. What is our observation? The rate is increased. Right. So that observation should be explained in a best manner. Palladium powder decreases the activation energy of the reaction? No. Right. Catalysts can't increase or decrease the activation energy of a reaction. What? Catalysts cannot increase or decrease the activation energy of a reaction. Then what is the function of the catalyst? Catalyst does not change the activation energy of the reaction, but it provides an alternative path with less activation energy. Right? Now in the existing path, it cannot change the activation energy, but it will provide an alternative path, another path, and in that path the activation energy is less. Right? So this is wrong. Second, palladium powder supplies energy to the reaction? No. Catalyst cannot provide energy to a reaction. Right? Third one, palladium powder helps to decrease the concentration of products? No. Right? Catalysts cannot increase or decrease the concentration of the products. Right? We only increase the rate of the reaction by adding a catalyst. Even though you add a catalyst or you don't add a catalyst, in both of the occasions you get the same concentrations. The only change that happens is you get the same amount of concentration at a small time, which means the rate is increased by using a catalyst. So we can get the products at a less time. But there is no change in the concentrations we obtain. So this is also wrong. Third statement. Fourth statement. one of the products bonds to palladium and increase the rate of the reaction by decreasing the concentration of products. Increase the rate of the reaction by decreasing the concentration of products. Again, they are saying that the product's concentration is increased. No, it cannot do any change for the concentration of the products, right? It cannot do any change for the concentration of the products. It only increase the rate of the reaction by providing a pathway with less activation energy. Fifth statement, at least one of the reactants bonds to palladium and the reaction occurs through an alternative path having low activation energy. Yes, exactly, that is correct, because they have given it through an alternative path having low activation energy. And also, what about this? At least one of the reactant bonds to palladium? Yes. Even both reactants can bond with palladium, right? So, intermediates are formed in the reaction. So, otherwise there is no reaction happening. So, at least one of the reactants should bond with palladium. And this reaction occurs through an alternative path having low activation energy. So, the answer is 5. Right. Twenty-sixth question. The number of moles of electrons given out when 1 mole of C2H5OH is oxidized to carbon dioxide under suitable conditions. Right. 26th question. Right. The number of moles of electrons given out when 1 mole of C2H5OH is oxidized to carbon dioxide. So, let's see. C2H5OH is oxidized to carbon dioxide. Right? The number of moles of electrons given out when 1 mole of C2H5OH is oxidized to carbon dioxide. So, how does this oxidation happens? Now, here we are having CH3. Then CH2 and OH plus oxygen, it will give carbon dioxide and H2O, right? So here we must have 2 carbon dioxide. 2 carbon dioxide is there and 3 oxygens are there. What about water? 3H2O, right? So here 3 times 2, 6 plus 7 O are there. Here 2 times 2, 4 plus 3, 7 oxygens and H are balanced, right? 6 no in both sides. Carbon you have 2. Yes, it's balanced. Now we have to find the oxidation numbers of each. Here now, how do we find the oxidation number? By using the electronegativity. We know that carbon is more electronegative than hydrogen. So, it gets here minus 1. Here also minus 1. Here there is no electronegativity difference now. So, here the oxidation number is minus 3. Then for this one, here minus 1. Here minus 1. Here plus 1. Because oxygen is more electronegative than hydrogen. Then minus 1, minus 1, minus 2. Minus 2 plus 1. Minus 1. Then what happens to the carbon of this one? Carbon dioxide. Here it has plus. Here also plus, plus, plus. Because oxygen is more electronegative than carbon. Because oxygen has minus here. Right? Oxygen is more electronegative than carbon. Therefore, minus sign is for oxygen. Here we get carbon plus 4. 1, 2, 3, 4. Right? So, plus 4 is the charge. So, what has happened? Minus 3 to plus 4 it has oxidized. And minus 1 to plus 4 it has oxidized. So, minus 3 to plus 4, how many electrons should be given for that? To form a minus 3 to plus 4, how many electrons should be there? Yes. From minus 3 to plus 4 means it has released how many electrons? It has released 7 electrons, right? And when it goes from minus 1 to plus 4, it has released 5 electrons, which means totally 12 electrons are released. So here now C2H5OH, 1 mole reacts with 3O2 and it gives how many moles of electrons? Therefore 12 moles of electrons are released. So the answer is 12. Answer is 5. Next, consider the reaction of an alkyne with dilute H2SO4 HgSO4 giving a ketone, a structure that could be formed during this reaction. Now they are asking a structure that could be formed during this reaction. It means when the reaction is occurring, right? When the reaction is going on, this should be an intermediate structure which is formed, right? Right, let's see the answer. Right, now if we take this first answer, you all know that alkyne reacts with dilute H2SO4 to give a ketone, right? Alkyne with this Hg2 plus dilute H2SO4, it gives a ketone. Now you all have to find an intermediate in this pathway. What is the structure? Now if we take this first answer, there is a double bond now. Previously it should have a triple bond there, right? If we go through this, CH2, CH, CH3, CH3. So this is the structure, because in every answer you can get that alkyne structure, right? C triple bond CH. Now if we go through the first answer, let's see if we go through the first answer. Now they have formed a double bond here now, which means previously it should have a triple bond there, right? Now what happens here is when dilute H2SO4 is added and a water molecule is added. So how can we form this one? You all know that hydrogens are added to the carbon with more number of hydrogens. Hydrogen is added to the carbon with more number of hydrogens, and to the carbon with less number of hydrogens, the hydroxyl group is added. So it will form a compound like this. Now this one has more hydrogens, so H is added here, and this one didn't have any hydrogens. So the OH is added for that. And form CH2, CH, CH3, CH3. Right, when during the first step. Next what it happens is H in this OH group, this one, it goes with the other carbon. It goes with this carbon and this 5 bond comes here. Right? This goes with this carbon and this 5 bond comes here. And it will form this. Now, there are 3H, CH3, then here CO, CH2, CH, CH3, CH3. So, a ketone is formed in this way. So, this is the intermediate. Right? This is the intermediate. So, the first is correct itself. Right? First is the answer. Answer is 1. Now, here what has happened in here? Now here is the double bond, but the OH group is not bonded to a double bonded carbon, right? These are the two double bonded carbons now. OH is not bonded to that, right? So we can't take the second answer, right? And what happens with the third one? So OH always it should be bonded with the double bonded carbon. Here we can't take it because OH should be bonded to a carbon with less number of hydrogens. So here it has happened in the other way. This should have hydrogen and this should have OH, right? And here it is bonded to a double bonded carbon, right? So what about this? Now here this in this double bonded carbon, right, it has an OH group, but here it has another CH3 there, right? So that is wrong because here it already has CH3, right? It means it forms like this. Triple bond is like this, ne? C triple bond, C, CH3, CH3. But this can't be. It means now if it has a triple bond, it should have like this, no? Triple bond C, CH3. No? But there is another CH3 group there. But we can't add the structure like that. So the structure itself is wrong in the fourth one. Again, fifth is wrong because OH is not bonded with a double bonded carbon. Right? In the intermediate formed within this reaction, this OH should be bonded with the double bonded carbon and it should be bonded with the carbon with less number of hydrogens. Right? So we can go with the first answer here. Next we'll move on to the 28th question, right? Next we'll move on to the 28th question. So consider the following half reactions. They have given half reactions. Magnesium 2 plus 2 electron, magnesium solid. Here the potential electromotive force is what? Minus 2.37 volt, and here Cr3 plus E0 value is minus 0.74. The question is asking about which of the following gives the overall cell reaction. We have to find the overall cell reaction and the E0 cell. E0 cell should be fine for the above electrons. So in order to find this overall cell reaction and the electromotive force, what is the first step that you have to do? The first step is we have to identify the anode and the cathode. How can we identify the anode and the cathode? The E0 value is lower for the anode. E0 value is lower for the anode, which means the more negative E0 value is the lower E0 value. So what is the more negative E0 value here? Minus 2.37 volt is the more negative value here. So magnesium 2 plus, this should be the anode. Because you all know minus 2.37 is lower than minus 0.74. So this should be the anode and this should be the cathode. And you all know even though it is electrochemical cell or electrolytic cell, anode does the oxidation and the cathode does the reduction. Now if we write the oxidation reaction, magnesium solid gives magnesium 2 plus aqueous plus 2 electrons. Then what is the reduction reaction? Cr3 plus aqueous plus 3 electrons, Cr solid. This is first, this is second. In order to balance this, I have to multiply first with 3 and 2 with 2. Then I am getting 3 Mg solid plus 2 Cr3 plus giving 3 Mg2 plus here aqueous plus 2 Cr solid. So this is the overall cell reaction. And if we calculate the E naught cell how do you find? E naught cell equal E naught cathode minus E naught anode. So the cathode is what? Cathode is minus 0.74 and the anode is minus 2.37 volt, right? This is also volt. So minus plus 2.37 plus 2.37 minus 0.74 is plus 1.63 volt. So 1.63 volt and this overall reaction we are getting 3 magnesium solid, right? So 3 magnesium solid is present in this one and the first one. Out of that we can go with this fifth answer because here the E naught value is also correct. 2 Cr3 plus 3 magnesium solid giving 2 Cr solid plus 3 Mg2 plus. So the answer is 5. Answer is 5. Next the 29th question. TiCl4 is an important industrial chemical. It can be prepared by reacting TiO2, Cl2 and carbon. The unbalanced chemical equation for the reaction is given below. So the unbalanced equation is given TiO2 plus Cl2 carbon. So that is the reaction. Then when 160 grams of TiO2, 230 grams Cl2, 60 gram carbon are made to react, the maximum quantity of TiCl4 that can be formed is. Maximum quantity of TiCl4 that can be formed is. Right, first we have to balance this chemical equation. Right, first we have to balance this chemical equation. So TiO2 solid plus Cl2 gas plus carbon solid gives TiCl4 solid plus carbon dioxide gas. Right. Then Ti balance. Here there are 4 Cl, so 2 Cl2. Then carbon, the Ti balanced. O2 okay. 2 Cl2 Cl4, 1 carbon, 1 carbon. So now the reaction is balanced. Now how about the stoichiometric ratios? 1 mole of TiO2 react with 2 moles of Cl2 and 1 mole of carbon to give so I'll write carbon dioxide at the top here. To give 1 TiCl4 and 1 carbon dioxide. So that is the stoichiometric ratios. Now they have taken 160 grams of TiO2. 160 grams of TiO2 means how many moles are there? What is the molar mass of TiO2? Ti is 48 plus 2 times 16, 32. You are getting it as 80. 80 grams per mole, which means 2 moles. Then chlorine. Right, for chlorine, the mass is 213 grams divided by 2 chlorine means 2 times 35.5. So that is 71 grams per mole. It gives 3 moles. And carbon 60 grams divided by 12 grams per mole. It gives 5 moles of carbon. Right. Now what we have to do is we have to find the limiting reactant here. We have to find the limiting reactant. So what is the limiting reactant here? TiO2, it has 2 moles. Now TiO2 to chlorine, what is the stoichiometric reactant ratio? 1 mole of TiO2 reacts with 2 moles of Cl2. TiO2 1 to Cl2 2. Now if there is 2 moles of TiO2, then 4 moles of Cl2 should be there to react. But here it has only 3 moles. So chlorine is the limiting reactant. Now what about carbon? Now if 1 to 2 ratio, if we react 2 moles of TiO2, then carbon, that is, now if we take TiO2 to carbon, that is 1 to 1. So if it is 2, this also should be 2. But here you have for carbon 5 moles. So it is present in excess. Therefore carbon is not the limiting reactant. Therefore the limiting reactant is chlorine. Limiting reactant is chlorine. Now we found the limiting reactant. Then we can get the answer, because according to the limiting reactant, the products are formed. Right? So now if we react Cl2 with TiCl4, if we get the stoichiometric ratio Cl2 to TiCl4. Now let's see if it is 3 moles of Cl2. Now how many TiO2 react with 3 moles of Cl2? 1.5 moles of TiO2 react with this Cl2. Right? So it is present in excess. Now if we take the chlorine and TiCl4, the stoichiometric ratios are 2 to 1. Here you are having 3 moles, then how many moles should be here? 1.5 moles. So 1.5 moles of TiCl4 will be formed. 1.5 moles of TiCl4 means, you all know we can get the mass from N into capital N. So 1.5 means 3 over 2 moles times the molar mass of TiCl4. Ti is 48 and 4 times 35.5. 4 times 35.5 is 142. So 190 will be the answer. Then that is the molar mass. So when we multiply this, we will get 285 grams. So the answer is second one for the 29th question. Answer is 2. 30th question. Consider the reaction below at constant temperature. PCl3 plus Cl2 giving PCl5. Kc is 6.5. 1.5 moles of PCl3, 1 mole of Cl2, 2.5 moles of PCl5 were introduced into a previously evacuated closed rigid container having a volume of 1 dm cube. Volume is 1 dm cube. Then which of the following best explains the way the measured pressure of the container changes as the reaction approaches equilibrium. Now, this reaction happens in the gas state, right? All of these three are in the gas state now. PCl3 gas plus Cl2 gas, that is giving PCl5 gas. Right, all are in gas state, and here we are having 1.5 moles. Then Cl2, it is having how many moles? 1 moles, right? And PCl5, 2.5 moles. And all of these are in 1 dm cube volume. Therefore, their concentrations are 1.5 moles per dm cube, 1 moles per dm cube, so 1.0, and here 2.5 moles per dm cube. Right. Now, we have to find, they are asking for a relationship between QC and KC. So, let's find QC first. You all know QC is the reaction quotient and Kc is the equilibrium constant. What is the difference between these two? Kc is the constant between the concentrations of the products and the reactants when it is at equilibrium. And Qc means when the reaction is not at equilibrium, the ratio of the concentrations of products over reactants. Right? So now first we will take QC. Right? Because they are asking the way the measured pressure of the container changes as the reaction approaches to equilibrium. It means it is still not at the equilibrium. So QC can't be equal to Kc. So let's see QC. Now you all know QC we find by PCl5, products concentrations divided by the reactants concentrations. Right? Now here PCl5 concentration is 2.5 moles per dm cube. PCl3 is what? 1.5 moles per dm cube times Cl2 is 1 moles per dm cube. Here 0.5 times 3, 0.5 times 5, which means 5 over 3. 5 over 3 means it is roughly 1.33. Right? Yes. 1 times 3, 2. No, right? 5 over 3 is it is 1.67 value. Right, and they have given what is the value of Kc. Kc is 6, this is small, minus 1 dm cube. They have given the Kc is, this is Qc, and Kc is 6.5 mole minus 1 dm3, which means Kc is greater than Qc. Right? Because Qc is 1.67. Kc is greater than Qc. Which means so, in which direction the reaction should take place in order to approach the equilibrium? The reaction should take place in the forward direction. Right? Reaction should take place in the forward direction to reach Kc. Why? Because Qc is less than Kc. So, in order to increase Qc up to the Kc value, we have to increase the amount of products. Right? So, the reaction occurs to the product side. Right? Reaction should occur to the product side. Now, what happens when the reaction occurs to the product side? Now, reaction, right now here see, here there are Now this reaction approaches to this forward direction, to the product side. Here there are two gas molecules. Here there is only one gas molecule. Right? So what happens when the reaction occurs in the forward direction? The number of gas molecules decrease, which means the pressure decreases. So the pressure decreases. Right? Pressure decreases. So the answer is pressure decreases and QC is less than KC. Answer is third one.